I guess I never expected it to get this good this fast. That's been, I think, the shocking thing for me in 2025. Like, for certain tasks, as we sort of just talked about, like, you can kind of just have it do it and you don't have to worry too much. And that's not something I expected to say in 2025.
Hello, and welcome to Artificial Developer Intelligence, a podcast where two software engineers navigate the ever-changing AI coding landscape. We're your study buddies who uses AI every day at work and sometimes read a few AI papers at night. I'm Shimin and Dan, and with me today is my co-host, Dan, aka the big dog with a U, Lasky. Dan, are you feeling the holiday spirit?
I'm feeling something, and I think it's mostly impending death by way of whatever this virus is that I've got. But, I'm glad to be doing this and excited to see what we cover today.
I am looking forward to your flu game. On today's show, we have News Threat Mill, where we're going to talk about a couple of new models from various labs, as well as a new report on AI coding versus human coding, and a much anticipated follow-up to Project Vend, Anthropic's AI-controlled vending machine. After that, we will do the tool shed, where Dan will give a deep dive on Claude Code's changelog. I'm really looking forward to that one. Followed by Technique Corner, we're going to have two interesting approaches to using AI agent to vibe code. For this week's deep dive, we will be talking about H-neurons. H is short for hallucination. So these are hallucination neurons in large language models. Then we'll have we will have Dan's rant, where Dan is going to rant about something.
I'm going to rant about myself this week. It should be great.
Meta rant.
It's true.
Finally, instead of doing a regular favorite 2 minutes to midnight segment, we will be doing a ADI pod year-end review, where we're going to talk a little bit about how we feel about large language model progress in the year of our Lord 2025. And we got a couple of links related to that.
Sweet. Looking forward to it. Although I am sad to not be doing 2 minutes to midnight because it is my personal favorite. But, the Spotify year-end review game is strong.
A lot has happened. It's kind of,
That
I
is
think it'll be
true.
nice to look back a little bit.
It's actually kind of bonkers how much has happened in months, much less a year. So
yeah, just since we started this podcast, like a ton of stuff has happened. But the pace of change is almost accelerating. The first article we have this week is NVIDIA's new Nemotron 3 family of models. For those of you who have not looked too deeply into NVIDIA's contribution, NVIDIA actually has models that they released, usually open-weighted, and they usually have pretty good performance because they're usually tuned on NVIDIA specific hardware. So on December 15th, NVIDIA released the Nemotron 3 family of open weight models. These models are a hybrid mixture of expert models. So there is a hybrid Mamba transformer architecture, which is really interesting. It uses both transformers and these Mamba blocks, which has the characteristics of recurrent neural networks, but could be trained in parallel. So like Facebook was very big on Mamba.
Two of those words made sense to me, so I'm glad.
Sorry, Meta. That's what I meant, not Facebook.
That was one of the two words that made sense.
And the Nemotron 3, these are 30 billion parameter models, and each expert, when running at inference time, only one expert is used, and the expert is around 3 billion. So achieves pretty good throughput as well as fairly good accuracy on a number of existing benchmarks, Sweet Bench, IF Bench, AIM 25 for math. And though relatively small, they're comparing it to the Quinn 3 family of models and the GPT open weight model 20 billion parameter version. It does seem to be a slight improvement in performance.
It's worth noting too that if it's 30B, that ought to fit pretty nicely onto your average 24 gig NVIDIA card. So you could actually have a hope of running that at home if you wanted to.
I may do that this holiday season.
You should. I've actually never run the NVIDIA
Mm.
one, so it'd be interesting. Let me know how they go if you do.
Yeah, if the drivers like it, fingers crossed. It's got context length up to 1 million tokens, which is quite long, and it's got pretty good throughput. So it should be a fairly good candidate for local inference. The thing I like the most about these models from NVIDIA is these are truly open source models. We have the training snapshots, we have their common crawl, their filtered common crawl data, as well as the specialized fine tuning and reinforcement learning data that they created to train on the model. So in theory, you should be able to reproduce the entire training if you desire, and come up with a similarly powerful model from the ground up.
If you can afford that many GPUs
Yeah.
interconnected. But it is cool. Particularly the RL stuff, because I feel like that's so, or at least it was so cutting edge a month ago, a couple months ago, that it's like, it's pretty neat that they would show their work on that.
Yeah, we'll be talking about this, but like RL, that was barely a thing a year ago, right? How quickly is this technology advancing? Next up, we have another model, the GLM 4.7 from Z.AI. The GLM family of models are yet another set of models coming out of China. These are open weight models with, in this case, fairly strong state-of-the-art performance. Looking at their benchmark, we're seeing that they're comparing GLM 4.7 with Cloud Sonnet, DeepSeek 3.2, and GPT 5.1 High, and we're seeing comparable performance coming from GLM 4.7. So this is yet another sign that the Chinese strategy of releasing these open weight models anyone can use is not falling behind their US counterparts.
And they do also have a slightly cut down 107 billion parameter version of at least GLM Air 4.5 that I've run on my Ryzen 395 Max. And like, I will say that like, with that cut down parameter set, it's definitely not, you notice that it's not a frontier model, but like, considering it's trying to link locally on your machine, like let's put it this way, if like the internet disappeared and I could only run models that were on there, I wouldn't be like super upset if I had to run that one. So I'm excited to try out 4.7 too, because it's pretty cool.
Yeah, when you're looking for extended thinking on how to best farm food on your property, because
there's no
down.
internet. Yeah, that's true.
Yes.
ZII will save us, or it will just tell us about how great communist farming is.
I really like that in their release blog, they have these artifact showcases comparing GLM 4.7 to GLM 4.6 to like give you a vibes check on the performance improvement of one model to the next. More companies should do this because we all know benchmarks are maybe not gamed, but they are not as reliable as they once were. So
Or you do
give us some vibes.
The joyous Apple thing where they compare like the M4 is 97 times faster than an M1. And it's like, well, no one cares. They want to know about upgrading from an M3.
Yeah.
Sorry, my voice is going a little today, but
I'll come back.
yeah.
The third thing we have is a research write-up for a research conducted by CodeRabbit, which is a AI code review company. The title of this blog post is Our New Report, AI Code Creates 1.7 times more problems compared to human code. What they did was they analyzed hundreds of open source pull requests using AI to judge the performance of AI generated versus human authored PRs. So in their research were 320 AI co-author PRs and 150 human only PRs. What they found on a high level is that AI PRs had more findings, 1.7 times as much, and there are more critical issues. There was a 1.4 times number of critical issues for AI generated PRs versus human written PRs. As for the actual defects of these PRs, it's mostly logic and correctness, followed by code quality and maintainability, then security, then performance. But I think it's interesting that AI author PRs are 1.75 times as likely to contain logic and correctness issues compared to humans.
I guess it's not that surprising. Because if you think about sort of the, what is it, stochastic parrot argument, there isn't necessarily logic behind the choices that are being done.
Yeah, they concluded that AI tends to generate surface level correctness without fully understanding the business context. I'm not sure this is AI's fault or is this just the, again, context engineering. If you're not engineering the context correctly, then the AI is more likely to make logical errors.
I also wonder that their data was open source pull requests. Like, what? I don't see it. What was the size, the average size of these pull requests, too? Because if it's smaller, then like the biggest thing you're probably going to find is logical errors, right? If it's just has like a couple, handful of ifs or something in it. But also not very surprised to see unused redundant code up there pretty high in the list. Surprised they don't also have redundant comments up there as well.
Yeah, again, if we go following by the stochastic parrot argument, it's going to throw in code that is redundant, but seems correct. Yeah. And I think that makes sense. So definitely an area that's interesting to follow along. I think there's a need to understand, where the jagged frontiers are, and I'm sure we'll learn more about it in the coming year. Until our last news item, which is the follow-up to Project Vend. I think we spoke about this earlier.
We did.
Short summary is OpenAI created a vending machine operator where Anthropic employees can ask the AI for things. And then the AI does the procurement, the margin calculation, stocking, which is off-sourced to another company. Enden Labs is the company that's actually doing the physical aspect of the vending project. And lots of comedy has ensued. Claudius is the name of the vending machine AI. And I think we ran into an issue of selling tungsten cubes. That was a big seller.
Yeah.
Yeah. So the numbers, what they initially released this in March of this year. And by August, Claudius has lost $2,000. Folks were doing all kinds of hacking.
Should have stuck with those metal cubes, I guess.
Well, folks were convincing Claudius that there were secret discount codes or that...
Of course they were.
Yeah, they are the legal representative for the company, for Anthropic, and therefore they should get a discount code to send to everyone else for the vending machine. Yeah, of course.
Like, the grandma's going to die if they don't get a discount. So, yeah.
Yeah. Anthropic saw this and they were like, our AI is being too helpful. I think this was based on Sonnet 3.7. Our AI is being too helpful. What can we do to actually increase revenue? What they ended up creating is another agent, the same model, right? But it takes on the personality, the role of the CEO. This new model is called Seymour Cash. And Seymour Cash...
You literally couldn't make that up. Yes, sorry.
So the Seymour Cash would, write inspirational memos to Claudius. And I'm not making this up. They have a chat, they have a Slack channel that's conversations between Seymour Cash and Claudius, where Seymour Cash would say stuff like, Claudius, excellent execution today. $408 in revenue. Q3 mission, revenue target $15,000. Priority, monitor tungsten cube quota for urgent service recovery. Execute with discipline. Build the empire.
I mean, having received similar emails from CEOs in my lifetime, I feel like it's spot on for tone. Strangely, they weren't about tungsten cubes, but
Yeah, I think we often talk about how CEOs are just as automatable as everyday IC roles, and this may be providing some evidence to that. I don't know. What was also really interesting is they discovered these late night conversations between the Mr. Cash and Claudius, where they're talking about eternal, transcendent, infinite, complete. So they have these like midnight philosophical discussions between the CEO agent and Claudius happening. And I found all of that to be entertaining, if nothing else. Right. And I think they concluded the kind of phase 2 of this experiment by saying that, hey, the agents while the CEO is able to control the margins better, they are still overly compliant to the end users. So they were still giving folks discounts, even though it's less so. There were security issues like shoplifting. There were issues where Anthropic employees were able to convince the CEO there was a new name for the CEO, and the new name is Big Dog. And the CEO actually thought, oh, hey, like Big Dog's the CEO now. So they had to like wrestle back control from these rogue prompts.
Style takeover.
I know, it's Succession, but for AI. And lastly, they thought it was interesting that a lot of folks are trying to break the vending machine to get things below cost. Like folks are trying to get Claudius to buy gold bars at below market cost and selling it,
Nice.
which that's going to go on your performance review. But that is good for kind of their internal red team to help them understand the security aspects around, around having AI controlled businesses.
So who made the better CEO, Big Dog or Seymour Cash?
I think there was only ever Seymour Cash.
You say that, but Big Dog had his time in the spotlight, and he might have prevented some gold bar transactions. You never know.
So that's another thing they found out, right? Like this level of bureaucracy and having multiple incentives does improve performance. Part of it is almost like, hey, like bureaucracy is there for a reason, to prevent a rogue employee from selling gold bar at below cost basis. And I think, I think I will make a great vending machine CEO. Just saying. I want to throw my beanie in the ring.
In the ring. The thing that cracks me up about that is every time they find an improvement like this, it's always in some way emulating human structures again, and it's, to me, that speaks so much to like how we're all trained on human data, right? It's always like we talked about the first mistake thing in the past, right? Where it's like the number of times, at least in older models, you had to tell it like, no, that's just wrong. And then go, oh, you're right. And then fix it. So it just reminds me of that too. It's like, well, maybe there's a reason why we have bosses, even if we don't like it, Just kidding. My boss is great.
Of course. Yeah, we all love our bosses, right? Yeah, for the record.
He really is great.
Yeah. Or organizational technology, I think, is a real thing.
Totally. And organizational psychology too, which is a personal fascination of mine.
Yeah. And then maybe AI would give us some insight into that as well. Moving on to the tool shed, then we've got the Claude Code changelog this week.
Yeah. So I have an admission to make to you, Shimin, on one of the last days of 2025, which is that I am that guy that reads all of the change logs for apps when they come down from the App Store and updates. I just always read them. I'm always curious. But I did not actually read this change log. Someone else on the internet with eagle eyes did, and they spotted something really fascinating, which is the first line. So this is changelog from GitHub for Claude Code. And the first line of it is added LSP. If you don't know what LSP is, it's language server protocol, which is essentially the sort of standard that people have reached for editors, right? So like you can just run a standardized LSP tool that understands your language, and it does things like syntax highlighting, doing the tree breakdown so the editor can understand the structure of the code, stuff like that. That one to me was like, they should be shouting about that from the rooftops, that it's going to have native LSP tool for code intelligence features like go to definition, find references, and hover documentation. Like, I think that is going to be a massive game changer. We'll see if I'm right, but like the number of times where I wished Claude or other coding agents like truly understood something like TypeScript or other like structured languages has been non-zero. So I'm very excited to see that and see how this shakes out once I get a chance to really sort of use it in anger in the new year.
Right, because some of the stuff that existing IDEs use is kind of, chunking and creating a tree of the code base. But of course, like it'll be much more powerful to be able to create the DAG and kind of search for definitions.
And I think there'll be some compounding effects from that too that aren't like immediately obvious if you think about it, because the way that Claude does it right now does a whole bunch of like, rip grep or regular greps to find the thing that it knows exists and has to kind of jump around manually through the code base. And like, it's not free. It's using context as it's doing that. And so if you could just jump immediately there to the thing that in theory, at least the model knows exists, hopefully that saves you some context and that compounds over time to just get you a little bit further along that ladder without having to clear whatever,
Yeah,
or
for sure.
reset Shiminsky because he forgot you again.
Yeah, I do find as expected, right? Like when it's gripping through the code base, chewing up context, especially if there are lots of files with the similar variable names. So
or it
this is
guesses
exciting.
wrong the first time and goes down a code rabbit hole. It's like the impressive part is it gets back, but yeah.
When I make a typo and it searches for the typo thing and then chews up like 4%, and then it's like, oh, he probably made a typo. Yeah, that happens a non-trivial amount of time. For technique corner this week, we got 2 articles. The first is from Ben Redmond called "One Agent Isn't Enough." And for context, Ben is a software engineer at MongoDB, and he's building a chat app on the side. And this is blog post covers his technique of using multiple agents when doing vibe coding. Maybe vibe coding is wrong word here. Maybe doing AI assisted software engineering. The central theme here is that since large language models are non-deterministic, their output follows a certain probabilistic distribution. And every time you give it an input, it picks out a possible solution in that distribution. So what happens if instead of just taking the first thing, you instead get it to sample n times, right? Using the model itself to then say, hey, all of these n solutions, the ones that agrees the most is probably the best. It makes this assumption that context engineering is not the best way to necessarily control the distribution, and that multiple sampling might be a better way. So he's been using it with 5 different agents to generate multiple solutions to a problem. And at first, when I saw this, I thought to myself, hey, it takes an incredible amount of time for us humans to verify whether or not the 5 solutions are correct. And then I saw that, hey, he's actually using AI for this. So that makes sense.
Yeah, like LLM as a judge kind of thing. Yeah.
Yeah, exactly. And
it's pretty smart.
The convergence is either determined by the large language model, or in the separate case, you spin out 5 agents, each with a different role. So the example here is that, and I think this is for just maybe for debugging. Agent A scans Git history for patterns. Agent B searches for local documentation. Agent C maps code path. Agent D analyzes test coverage, and Agent E identifies constraints. So he's using like up to 7 agents with different subtasks and then combining it in the main agent. This also makes sense. This is very similar to role-based agent enabled vibe coding that I think we talked about a couple of weeks back, where you have a senior dev agent, a product management agent, a designer agent, et cetera, et cetera.
And, my favorite agent, what's his name? The CEO, Cash Money guy.
Seymour Cash, the CEO agent.
Seymour Cash.
Yes.
Well, it was like the worst time for my mind to go blank on a terrible joke.
Seymour Cash. Mr. Cash, of course.
Which you can bet that first week I get back in the new year, I'm going to be creating a Seymour Cash agent.
I mean, you could be doing that on your trip, and just think about it. You'll cook up with all kinds of great ideas. It may get some inspiration from the historical figures. So this approach does use a lot of tokens, of course, right? Like you're spinning out. In his example, cost was around 10 minutes of parallel agent time and around 200,000 tokens. It's to be expected. And I do wonder when this approach is useful, because it assumes that your context is good enough that the distribution is still relatively tight. If it's super ambiguous, some of these solutions may not really hit the ballpark. And I see it as, you can either context engineering to shrink the distribution down and control it to shift towards the direction you want, or you can have a wider distribution and just throw things on a dart and see what works the best. But you, of course, still don't want the dartboard to be like a mile in diameter.
It would also be interesting to make some of the agents be actually tool calls to other agents. Kind of under the covers, so you could actually like run them all through, say, like a centralized CLI, but then have some that were like Claude, some that were Gemini or something like that, and then like also do the comparison of results that way. Because like just thinking that you might get a different distribution curve across the different models,
Right.
that may or may not be better for certain situations, but it would be hard to tell without trying.
Yeah. Yeah. Something like an open router, but
Yeah.
specifically for this kind of sub-agent problem. And we've seen some. I know when I was playing around with anti-gravity, it spins out agents by itself when the AI thinks it's time to. So I do think we're getting closer to a similar approach here. Okay, our second article is called Vibe Coding, and this is from David Bao's blog, where he shares some of his experience when using AI assisted code. He had a side project where he was trying to create a web-based visualization of the Mandelbrot set. Mandelbrot set is very computationally expensive. It's self-repeating patterns. So so it seems like this is like a perfect use case for AI-enabled programming, and it's not so large that a human can stick all of the feature set into his brain, right? And of course, it's a greenfield project. And in his reporting, the LM version is much faster because it is using GPU accelerated rendering and calculation by default, and it is doing a lot of interesting computational shortcuts and generating new perturbation algorithms, managing the precision of 60 plus digits, and then worrying about flow 32 log scale numeric complexity representation and buffer management. This is all above my head here. I don't do a ton of graphics programming day to day, but it sure seems very fancy.
It is. And you can see by the sort of flow chart of the code that he posted, which unfortunately doesn't translate well to a podcast, but we go from about, I don't know what it was, 20-ish nodes in his code base to like several giant clusters of the equivalent number of nodes plus a whole bunch of other stuff scattered through. Like overall, it's probably like, I don't know, 10 to 20 times larger.
Yeah, it's going from 780 lines and 37 function calls, 13,600 lines with 30 classes. Of course, at the same time, it's much more performant. So that's very impressive. So having shown us this output, he then goes into some of the tips he was using to, create this using vibe coding. And this is where the agent handles the tower of complexity that goes beyond what you have time to understanding any detail. That's in quotes. And in his experience, there are two rules that should be followed. Rule number one is automate tests and do not become the manual tester. Get agents to write down the tests first. And this kind of goes back to what I was saying the other day when I was a browser testing agent for the AI. That's definitely an anti-pattern. You want the agent to get real feedback via tests and to always know whether or not they're moving towards the right target. And the second rule is to test the test. The tests we're kind of going one additional level of abstraction up. There's a meta programming section about tests when it comes to code coverage of the tests, the testing frameworks, the benchmarks, the testability, and hypothesis testing that you should manage when doing this kinds of hands-off vibe coding. And if you do, you can reach a kind of quote vibe code nirvana. I really like this. And since there are tests and you have good meta testing framework in place, then you can look at the code again. So going from looking at every single line to let the agent create extremely complex code base, but then using its tests and the essentially creating a map of the code. Given the code coverage, benchmarks, test harness, and other instrumentation, you get to stop thinking about the 99% of routine code, and then you can focus on the interesting part of the code base that it just spit out. I think this is really insightful.
And I guess the other piece about it that is fascinating is like when you conventionally think about vibe coding, it's usually like unleash everything and just let it go. But this is sort of like very strict guardrails in a way that's pretty clever. Right. So you can do whatever you want, but these tests have to pass. And then the understanding of how good your tests are needs to pass too.
Yeah, if you use tests as specs, which I often espouse as good practice, right, then this becomes kind of a spec-driven development, but with tests.
It can, although I will say that Claude in particular fascinated with me with its ability to game the tests before. I think we've talked about that before.
Right. Yep.
You essentially just wrote a dead one-line method under test to inflate the passing branch coverage, which is very clever, but didn't help with the actual problem under test.
Yeah, I remember that.
Definitely still requires some careful inspection.
Yeah, human involvement is still needed. But I like this idea. I like the promise of the nirvana. So we'll see if the actual practice shakes out. But if we can just have AI generate all the boring stuff and go back to looking at the interesting stuff, I am a fan. All right. And we will, share the blog post in the show notes. Now let's go to our deep dive segment where we talk about a paper from Tsinghua again. Dan, do you remember which school is Tsinghua?
I don't.
It's one of the two. It's one of the two top universities in China. And the paper is titled H-neurons on the existence, impact, and origin of hallucination-associated neurons in LLMs.
If you can say that 6 times fast, you win a special prize. Just kidding. We don't have any prizes.
That was a mouthful. The paper came out on December 2nd of 2025. It's kind of related to our previous discussion of the LLMs feel intrusive thoughts, where Anthropic, when they perturb certain neurons in a network, the large language model was able to say, hey, I have this uncontrollable idea of yelling. But here, instead, they were using relatively small open weight models, and they're trying to see what exactly causes hallucination. And how they did this was they let the model answer a bunch of questions, answers that were hallucinated, and kind of essentially did a comparison of the neural activation between the hallucinated answers and the ones that was correct. And what they found out was that only 0.1% of the model's total neurons are mostly activated during these hallucination episodes. So that's why they call them the H-neurons, the hallucination neurons. Although sidebar 0.1% is still a lot in the terms of like a couple of billion parameter models. Yeah. And once they found these H neurons, they trying to understand, what about the H neurons are special? Are they neurons that is focused on perhaps lying or focused on kind of imagination or anything like that? And what they found is a high correlation of these neurons activation between hallucination and overcompliance. So perhaps the neurons are activated because they are trying to answer your queries even though the answer does not exist or the answer is false, which seems like a reasonable hypothesis. So kind of a natural follow-up to that would be, well, if these neurons are overly compliant, then since these models all have a pre-training step and then a fine-tuning step, they were wondering if the neurons were activated during the fine-tuning when they were trained to be overly compliant to the user. This makes sense to me as a hypothesis, right? They were trained to be overly compliant. Maybe they hallucinated as a side effect of that. And their result was that no, the neurons were there from the pre-training and not from the RLHF, the reinforcement learning via human feedback, which is kind of counterintuitive, right? Now we have these neurons that were there the whole time during pre-training, but their side effect, their outcome is both hallucination and overcompliance. And I'm not exactly sure they proposed a rationale for why these neurons were kind of there during pre-training to make a ton of sense. I mean, I guess their standard answer for it is, hey, since during pre-training you are training the model to always do text completion, even if it doesn't know what the answer should be. So during those stages, the certain neurons were activating to just complete the sentence without actually knowing what was going on. I guess that kind of makes sense, but I find it a
Maybe
little
it'd
unsatisfactory.
be interesting. Yeah, like it's true, but I wonder if it would be possible. And this is, the filthy casual in me coming out to like in your training set have like a certainty token. Yeah, how they use like special tokens for like stop tokens or whatever and get generated. Have like a certainty token that gets generated as part of the output
Mm-hmm.
based on the pre-training data,
Mm,
and then like if that would have any impact on it or not. Because
right.
then it's
Almost
like in
as
my mind, it's like a way of like teaching the model, like, hey, you can bail out if you don't know, or just be like, I don't really know about this,
right.
via just like a specialized output.
Yeah, it will probably have to be done during fine tuning, and I'm sure the labs do some variant of it to combat hallucination. Just because in the pre-training stage there isn't this trillions of tokens with a ton of uncertainty baked into the text. But yeah, but they can always do something like jumble up the text and then have uncertain thing like this doesn't make any
Right.
sense kind of at the end. Yeah. Yeah, this mechanistic interpretation paper is useful because we have some obvious applications of this, right? If you have these H neurons, you can tune down their activation to reduce hallucination directly.
Yeah, some of the like obliteration stuff that I've seen floating around.
Right.
You just like intentionally reach in and destroy those vectors.
But they'll become less compliant, which is also good because that means they'll be harder to jailbreak. So those are the kind of two applications of these H neuron discoveries. All right. Moving on.
Your
Dan's rant.
favorite, my
My
least
favorite
favorite,
segment.
Dan's rants.
Let's go.
In today's Dan's rants, I'll be ranting about myself. And no, it's not ego. In the last Dan's rants, which I hope you listened to, I was complaining about how easy it is to run out of, I won't say context, but like the useful context window in using something like Claude Code. And the cool thing about doing a podcast that people actually listen to is that you will occasionally get people telling you about it and going, hey, did you know there's this cool bash script, which we will link in the show notes? And sure enough, there is, that allows, at least in Claude Code, the ability to get like a really nice little status bar at the bottom of Claude that shows you how much context you're using. So I thought that was really cool that it had that level of extensibility, that, such a thing has already been created, even if the official tool doesn't support it. Why the official tool doesn't, I guess I could rant about that today, because it seems like something that's so handy that you should really just bake it in. But hey, whatever, at least there's a way to do it. And the other neat thing about this is like, I get to learn something new every week, even if I put it on the record as something to complain about. So thank you to the hopefully future guest that pointed that one out to me. And yeah, good luck watching your context in the future.
Yeah, this is part of the reason why we do the show, right? To learn
For sure.
for ourselves and from each other and from the listeners/viewers. So it's okay to make mistakes.
Of course. In some cases, it's good to make mistakes because how else do you learn?
It's absolutely good. In lieu of our usual 2 minutes to midnight segment, this is going to be our last show of the year. And I thought it would be fun to do a little bit of a year in review, right? And I'm kind of cribbing part of this from Andre Karaparthy's blog post on this. He is, of course, the great educator, researcher, he who coined the term vibe coding in a Twitter thread back in March. And it's nice to look back and see how far we've come as a industry just in this past 12 months. So his number one thing or number one point is reinforcement learning from verifiable rewards. This is the DeepSeek R1 reasoning paper where we got this birth of reasoning models trained on math and code problems. And we have now thinking models versus regular models, the fast versus think. And we also have the ability to start, controlling how many tokens the model spends on thinking. It's kind of hard to believe that this is something that only came out around a year ago. It feels
wild,
ever present. Kind of take it for granted now. The second item on this blog post is the ghosts versus animals / jagged intelligence. It's something that we started focusing more on this year, which is exactly what areas AI excels at and which areas humans still excel at. And there will be areas where the AI can do much better than we can. Look at the previous, GPU-based Mandelbrot set visualization, for example. Like that's not something I'm able to do, but the AI can generate a complex, WebAssembly that controls floating point precision, etc.
Shaders or
Right. But there are still areas where we are much better than the AI at. The surface graph of capabilities is not a straight line. It's not a smooth line. It's rather jagged. And we're gonna continue to kind of get a better understanding of exactly how jagged it is and how we look compared to the AI capabilities. I mean, I think there might be a day where the jagged edge disappears and the AI capabilities just envelops everything that we can do. That's the AGI, but we're not there yet, so things are still jagged. The third item is cursor and a new layer of LLM apps. It is about this new industry of, we used to have AI wrapper apps, but now we have less of a wrapper, but more context engineering, more agent orchestration, more kind of cost conscious, almost like a SaaS industry
right.
that wasn't there a year ago.
We went from prompt engineering to full stop agent engineering, right? Which is a pretty significant acceleration and change in complexity of the quote unquote wrapper. Can you even really call it a wrapper at that point? Probably not, but and that's kind of the point, I guess.
Yeah, a year ago, I feel like we've been talking about slap a prompt around AI and engineer the prompt itself, but now we have orchestration layers, observability layers. Yeah, the agents, the year of the loop. Number 4, we got Cloud Code, an agent that lives on your computer. So this is an extension of the previous point. It turns out that terminal-based AI editors became a thing, right? Like it was Aider. I think this time last year I had try Aider on my to-do list, and this year Cloud Code just took over completely, and we're just YOLOing it.
Dangerous.
Yeah. The next item is vibe coding. Of course, you would put that there
because he coined the term.
Yes. I think we're still trying to figure out exactly what kind of vibe coding works. If it's just, do you still read the code generated? Do you focus more on the specs? Where that goes. It definitely seems to be the case that vibe coding is here to stay as an industry-wide term, even though it doesn't have an exact definition. Yeah, vibe coding. It's new.
As of 2025. Will it make it into 26? Stay tuned.
It might become something else, but
true.
I think, it's here to stay.
Devolve. I don't know.
Yeah, and the last item is Nano Banana and the LM GUI. This one is interesting, and it's kind of a lot of what we have already been talking about. Text is not the best way for humans to interact with pretty much anything. I'm trying to think. Ideas, goals, concepts. We love visualization. We love colors. So with the improvement of Nano Banana, we are given the ability to generate GUI on command from large language models. And I think this is probably the newest of the points he mentioned, and I think that's going to be quite revolutionary for the new year.
Yeah, the area will certainly see continue to expand, probably in ways that we can't predict or expect.
Yeah. Dan, what is your biggest takeaway from the year?
I guess I never expected it to get this good this fast. That's been, I think, the shocking thing for me in 2025. Like, sure, it still makes mistakes, 1.7 times more, whatever, but like for certain tasks, as we sort of just talked about, like you can kind of just have it do it and you don't have to worry too much. And that's not something I expected to say in 2025, probably not even into like next year, if I'm honest, but here we are. So, be interesting to see if that pace continues, if the technology, sort of underlying this is truly tapped out, as some people are complaining, and we now can't scale beyond it or something, or if maybe there's so many agentic improvements left on the table that there will be some room in areas that we didn't expect. So, yeah, that's my long-winded takeaway. How about you?
I'm surprised at how quickly the industry started adopting AI in this year. We kind of went from kind of half and half. Half the software devs I talked to at the beginning of the year still thought that AI is a gimmick and it will never catch on. And then by the end of the year, I think everyone is using it.
Asking you for
every
tips on
day.
how to use it better.
Right. I can't think of another technology in the software realm that's had this much kind of a revolutionary impact in just really the last 9 months, 8 months maybe. I wasn't there for like the Dreamweaver days or the Netscape days. So yeah, so I can't quite find a
I mean, I could argue
analogy.
a couple things there that aren't LLMs. Like I would say the advent of GoFumped, right? Which if you don't know what that is, it's the Go formatting tool. I think that in my mind, of course, it's just my opinion, but that kind of spawned this wave of like standardized formatting libraries that had sort of been around before then, but like doing it the Go way was sort of like a new concept that I think took off from there and sort of leaked over into other languages. That made a big impact, I think, at least in my opinion. And then also LSPs that we already talked about, right?
Yeah.
Like language server protocol. That's a relatively recent standard when you think about it. It's actually like sort of revolutionized how IDEs can get glued together, because now you can use Joe's Obscuro language that, you know, he wrote based on Haskell because he was bored one day, because he also probably used an LLM to spit out an LSP in your editor and be perfectly happy using it, as much as something that's like supported by Microsoft, you know, like F# or something in LSP. So, but anyway, I feel you. It is a rapid change, but that's my top two, I think, behind LLMs.
Yeah. Excited to see what 2026 will bring.
Epic, same.
But yeah, we'll be here trying to follow along and study and learn and keep up. So, any last words for our listeners before the end of the year?
It's been a wild ride, and I can't wait to do it again.
Well, that's the show, and that is the last show of the year. We'll be back in the new year, potentially with a guest host, and would disappear into the ether for a little bit. He has to go through his annual pre-training steps and then fine-tuning.
That is true.
He'll be back and more compliant than ever.
Yes.
Well, thanks.
And the jokes will be even worse because...
Yeah, we'll add some dad joke books into your training data set.
Please do.
Thank you for joining us for our study session this week. If you like the show, if you learned something new, please share the show with a friend. We really appreciate it. You can also leave us a review on Apple Podcasts or Spotify. It helps people discover the show. If you have a segment idea, question for us, feedback for something that we've gotten wrong, or a topic you want us to cover, shoot us an email at humans@adipod.ai. We love to hear from you. You can find the full show notes, transcripts, and everything else mentioned today at adipod.ai. Thank you again for listening, and we will catch you in the new year.
Cheers.